We built a simple model that uses Boolean logic to determine whether services were supplied or not, depending on combinations of the presence or absence of species and their functional traits, which we modeled as a bipartite network. So where species are on one side, traits are on the other, and there's links connecting the two if a species has a certain trait. So this is a Boolean model because we use these Boolean functions, these logic operators, where that kind of span from one side where there's complete redundancy among all the species. So every species is substitutable, and therefore lots and lots of extinctions are tolerated on the network. You only need one species to supply the service effectively, and that's the OR Boolean function, because you can have this species or this species or this species and so on. And at the opposite end, we have the AND function, where all species are essential, and so no extinctions are tolerated at all. You need this species and this species and this species, so on. So we measured the robustness of services as a distribution of extinction tolerance values across all the different combinations of simulated species extinctions. So we removed species one at a time from the networks in all possible combinations. And so we made some simplifying assumptions to demonstrate theoretically that the robustness of ecosystem services scales with a simple measure that we call network fragility, which is based on the number of species and their traits and the connections between the two in these bipartite networks. So finally, we tested these predictions on real empirical networks that can represent ecosystem services, so things like plant pollinator networks that we got from the Web of Life database.